Hey, Robert. Oh, 33. I thought I did this one yesterday. Maybe not. I bet Joyce isn't watching, but Joyce, if you're watching, we miss you. Okay. Whoa. So pi here is a constant. And this is that power rule. So maybe you weren't telling a story. Maybe you don't know power rule. Because you said whenever they said in here, you're like, I don't know that. And I said, that's the power rule. This is the power rule. So you just bring the exponent around front, right? And then subtract 1 from it.
I did that, but it didn't feel right.
That's right. Okay. Wait, yeah, can you do 28? Whoa. Okay. Do which one? 34. Whoa. So again, that's a constant, right? Agreed? So derivative here would be, I'm going to bring it around front. I'll probably throw that in parentheses to make sure I keep all that straight. And I'm going to subtract 1 from it, which just leaves me with square root 2. 100%. Can I or will I? No, I'm just kidding. Okay, 28. It feels so good to feel better. Y'all don't understand. I think I had the flu. I didn't get to the doctor. What did you have? You were. I wasn't throwing up. I was throwing a fever and congested, and I'm still a bit congested. But yeah, I wasn't throwing up. Thank you. All right, so we're gonna have to chain this. Derivative of the log first, which is 1 over 10 to the x, right? Now I need to do the derivative of 10 to the x. And I can't do the power rule for this because the exponent is a variable. So hot pink sheet, what's the derivative of a to the x? Yeah. A to the x times the natural log. Okay. So if I put this in one fraction altogether, right? See what's going to happen? Yeah. If what's in the top of the bottom. A is just a constant. So it's saying if this is any value, this is a non-variable, is essentially what it is. No, because this is, what I'm doing is, remember, if I've got the log of x, and I take the derivative of this, it's going to be 1 over x, but then I have to follow it with the derivative of x. So it's just because what was in parentheses here, right, was something more than just x. So that's why I followed it with the derivative of that. It's in the bottom because I put it in the bottom. It's my actual x. Like if it was y equals the log of, I don't know, if it was just 10x instead of 10 to the x, well then the derivative would be 1 over 10x, but then I'd follow it with 10 because of, right. You with me? Okay. Yes. You always change this x part. And in fact, you could follow any of these up with a dx after it because you're finding the derivative of the x itself, whatever. And whatever you're plugging in for the x is what you're changing. If that makes sense. What else? Well, you already asked that one. All right, so again, I'm back to the pink sheet. I'm going to use that very last bottom right, log base a of x, right? So the derivative here would be 1 over x, my x is e to the x, times 1 over the natural log of a, and what is a? 10. Now I chain it. None of this is chain yet. Now I'm going to chain, and whenever I chain, what am I finding the derivative of? E to the x, right? So what's the derivative of e to the x? E to the x. Well, that's going to be in the top and the bottom. So just have 1 over log. Yes, ma'am. 26. Y'all know that one. I think these are fun. You don't have a problem with them? You think it's the easiest lesson? Well, now you would think chain is easy because we're chaining so much now. You're kind of doing it. Yeah. Yeah. You didn't like the inverse trig? Even with the sheet? The hot pink sheet? Yeah, it is. All right, so I'm going to use, again, that log. So I'm going to go 1 over x. I'm going to have a lot to change. Times 1 over the log of a, and my a is what? 3. Now I chain. So what am I chaining? I'm chaining all of this. So I'm going to multiply by that chain there. The original x, whatever you would have plugged in, like this would be my x, right? Log base 3 of x. So this is going to be my dx, my derivative of x. All right, so derivative of 1 is, of course, 0. So I've got to do the derivative of this. That's going to be a product rule. Actually, no, it's not a product rule. Why is it not a product rule? Not x. Log 3 is a constant, so it's just... And again, look. Isn't that beautiful? You might just write the question wrong because that was from the original problem. What else? How many of y'all are not going to be here next week for the SAT? That's what day? Thursday? No, and Jalen and Cynthia, who else? Jalen. I'm just going to work this problem. 4. Who else in the back? Nobody. Campbell, no you. Vaughn, no. I bet Robert will. All right, derivative here. 1 over x, but x is x squared, times 1 over the log of 4. I don't know what I'm going to do about that test is why I was asking. Let me go ahead and chain it. That's 4. Well, testing on Wednesday put us to review. Wait till you see today. We might need the extra. I'm Well, it's the last lesson of the last unit. It's logarithmic differentiation. Not made up. Yes. I've got you in my snares now. No, you can't drop. If you drop the second half, you have to pay like $65. They've already bought your test. Why'd you say it like that? Y'all aren't dropping, are you? But it would be silly to drop after, even if you're not doing well, it would be silly to drop because you got like another month of material and then we're just straight review. And then past like May the whatever, we play board games. Yeah, but we start skipping and picking up pieces and things because we don't do BC. All right, anything else from your homework? In what class? Y'all won't take a lot of tests in here past. That's us here too. That's the way it is, and like your grades are coming just from. This is not like you won't see logarithmic differentiation on any of the required topics, but it is a way to find a derivative when you feel stuck and you cannot find the derivative of anything and you don't know how to do it. You can't see how chain might work. You can't see how anything might work. It is a way that will always work for differentiating anything that is difficult to differentiate. It can get messy, but it's kind of like quadratic formula, right? It always works, but you only want to use it as a last resort. Kind of the same thing for me with logarithmic differentiation, but it is a great tool to have to be able to use. So I think I'm going to show you. So if I had something like, and I'm just going to use this example that they have in the book because it looks really nasty, which is a good candidate for logarithmic differentiation. 20th power. It looks terrible, right? So if I said, find the derivative of f. Yeah, okay. Yes. Okay, y'all say chaining, but then you'd have a product of 3. Do it. If I was doing this one, I would probably, if I did not have logarithmic differentiation, if I looked at this, I'd go, okay. I can definitely do, like y'all said, the exponent, the power rule, right? And I can start working inside. I would do quotient, but then within quotient, I'd have product up there in the top. I'd have, it could be done, right? It could be done. But let me show you what logarithmic differentiation does. Now you have to remember these log properties, so let me just run through those real quick over here to the side. Let's say x times y is the same thing as log base b of x plus log base b of y. Y'all don't remember these? If you're dividing, right. You can subtract, oops, I didn't mean to put b. And if it has an exponent, do you remember what you do with that? You put it in the front. So those are the 3 main logarithmic principles that we're working off of as we work with logs. Expanding and condensing or whatever. That's just those from Algebra 2 and then again in pre-cal that we. Remember, calculus involves so much more of everything else, more than it does calculus itself. It does. Calculus is more of everything else than it is calculus. Calculus concepts are everything you use with the calculus. Newton? There's a controversy on who actually. I'm going to change this to Y just so you see what's happening a little bit easier. Again, if you want to go through the headache of differentiating this, Mac. But what logarithmic differentiation does is it says take the log of both sides. I always do natural because it's just easier, but it could be whichever you want because all the properties are the same. No, do natural log because it's going to make our derivative. Now take the derivative of both sides. Now this is implicit differentiation, right? Because I'm taking the derivative of y, right? So it's going to be 1 over y dy dx equals. Now, before I take the derivative of this side, I should have done this first. I should have expanded this a bit before I took the derivative. Just pretend like it's still y. Let's expand this just a little bit so I can show you how this works. All over the place. I'm going to change this to 1/3 because remember that power property? Now I'm taking more steps in this than what you would need to take, but just to show you. I'm going to get these split up in their own pieces to help me as I take the derivative here. I'm going to bring this around front. 1/3 log, and then I've still got all this stuff in here, right? And you might not like this. It's not always my favorite, but it does work well. And now I'm going to start expanding this, okay? And I'm going to get it expanded as much as I can. So what do you think the first thing I can do to expand it? You don't want steps for this? So, well, the thought process is you're so good, because when we did this in pre-cal and algebra 2, you're so good at expanding logs. All right, so I got 1/3 log of, I'm going to do the subtraction first, okay? So I'm going to do x minus 20 to the 20, that's a 2. I don't know, because I'm losing my mind. Oh. Huh. Move it? Oh, I just, that property. I'm going to keep splitting up. Maybe this I bring around to the front here. I'm going to split these up with addition, and also I'm going to bring these around to the front of them. I'm going to do all that at one time. 1/3, 20 times the log of x minus 2, plus 3 times the log of x plus 1. This is the hardest part of it once we get this. Everybody agree? Yeah. got to be a certain color. All right. No, because we're not taking a derivative yet. All we did was just expanded it. So we've done no calculus yet. We're fixing to that. Now take the derivative of both sides. So step 3. Derive. Oh, derivative. That doesn't look right. Ah. Okay, so on the left side, I've got 1 over y dy dx. Now we're back to where I want to be. Equals. How am I going to take the derivative of all of this? Oh, good gracious. But remember the coefficients in front just stay out front. So I'm going to do 1/3 and 20. Well, what's the derivative of the log of x minus 2? 1 over x minus 2. Plus, what's the derivative of this one? 3 times 1 over x plus 1 minus, yeah, and you could be writing them this way, right? Because that's really what they are. They're on the top. I just didn't want to write again. I just put them there on the top of the fraction so I didn't have to rewrite the problem again. Everybody agree there? Solve it for dy dx. No, we're not even doing all that. This is one we're going to leave. Just multiply by y. So now I have dy dx equals y over 3 times 20 over x minus 2 plus 3 over x plus 1 minus 10 over x plus 5. I don't want to leave y in there, remember. I never want to leave y in there, so what do? Well, it was 1/3 if I multiply both sides by y. Do you know what y is? It's what we started with. Just write it. It's a lot to write, but it's really not. Remember in the beginning, if you were doing the regular old derivative of this, how we would take, this was a 1/3, we'd multiply by 1/3 on the outside, keep the inside the same, and have that exponent. That's going to start coming out here. We'll start seeing it. So this would be 1/3 times y, and y was the cubed root of x minus 2 to the 20th, x plus 1 to the 3rd, over x plus 5 to the 10th, times all of this. It looks terrible, but I really haven't done a lot of work. It's just a lot of writing this stuff out. You think that was a lot of work? I put it back to 1/3 y since I forgot y was already a fraction. Y over 3 or 1/3 y, those are the same thing. Yeah. It just makes it a little bit easier when it's something like this. Yeah, you leave it just like that. No, that's it. Yeah. That's the theory. Because it's just one. Yeah. Do it on the calculator. 6 to the 10th. And then times. You just go ahead there. Speedy. On the calculator. Oh, you got it. I got negative 0.017 for the whole thing. I did 8 over 6 to the 10th. And I took the cubed root of that. Whenever we're looking at the graph of it, we estimate it to be 0. Is what you're thinking. But keep it in your calculator.
And this relates to a graph that,
What'd you get? 0.034? Negative 0.034? Yep, that's what I got too. Yeah, you're wrong. That's wrong.
I really don't think it's wrong. No, but like, if you do it the other way, they still.
Are you saying my derivative's wrong?
No.
Are you saying my derivatives?
Well, do it the other way and it's still keep But what if it's not?
It's happened before. Let's do one application and then I'll be done. Tell me we're gonna have 100 homework problems that are due. 105, Stella.
No, I know what it is.
The spread of a rumor in a certain school is modeled by the equation. It's one of your homework problems, by the way. This what? The spread of a rumor in a certain school is modeled by the equation. Where P of T is the total number of students who have heard the rumor T days after the rumor first started to spread. This is actual scientific evidence. I don't know why y'all are laughing. This is a true problem. They studied this. Yeah. Yeah, yeah. Might be. It might be. Might have. All right, so P of T is the number of students who heard the rumor. T is the number of days after the rumor was started. Are we clear on what the equation is modeling? About how many initial students heard the first rumor? Initial. Well, the rumor. Who first heard the rumor? Yeah, that would be at 0 days, right? So how many students first heard the initial rumor? Estimate. What do you think? Yeah, well, that's what it says. Estimate the initial number, but yeah, work it out. That's why it's an estimate. They got 18. So about 18. So I would say if you said 17 or 18, you'd be okay. Everybody sees how we got that, though. We plugged in 0 for the number of days. All right. This is P. All right. Part B. There's part C. There's stuff to say. All right. You ready for this one, Brian? Here comes the calculus. How fast is the rumor spreading after 4 days? You're actually right. First derivative. But I knew, well, because it's not really velocity. So I meant to say yeah. Okay, but it's the derivative is what I'm getting to. Right, the first derivative, like Avery said, the first. Because it's asking for the rate. How fast is the rumor spreading? 4 days. And at a specific point in time, at 4 days, how fast is the rumor spreading, right? So, that's all part B. It's just how fast is the rumor spreading after 4 days. So do it. How are you going to find the derivative of... Are y'all doing the log or are you doing the... You're doing log? You'll keep doing it whichever way you want to. If you want to do quotient on that one, you can do quotient. Yep. This is why I think something's wrong with me. I'm not going to lie, I wasn't doing that. Well, no, you can't because it's not to the whole thing. Because if I have, you make me nervous, Stella. You make me so nervous. You make me mess up. Ignore. All right. If I do it, if I keep with logarithmic differentiation here, and I take, I'm thinking ahead to whenever I take the derivative, right? I'm going to have 1 over 1 plus 2 to the 4 minus t. And then I've got to multiply by the chain. So I've got to find the derivative of this, which is going to be the derivative of just this, right? Which is my a to the x, which is on my pink sheet, which is, so the derivative of a to the x, remember, is a to the x times log of a, right? So this would be 2 to the 4 minus t. ln 2, but then I've got to chain again because this is got a function. You see what I'm saying? Should be a double chain. Yes. So this one might be easier to do not logarithmic. Okay, let's not do logarithmic differentiation on this one. Let's just do the derivative here. Y'all okay with that? I'm going to make this 300 times 1 plus 2 to the 4 minus t. I'm going to still have to do a lot of that chain rule and stuff, but then I won't have the log embedded in that as well. I always make it -1 because I hate quotient rule. Y'all know that. All right, so I'm going to do power first. -300 times 1 plus. Stop. Why? Because you did it? Great. When you squared the bottom? Yes. All right, so now I got to chain it, right? So same thing, right? This is 2 to the x, so it's going to be 2 to the 4 minus t, natural log of 2, and now chain that, which would give me the -1. That makes sense, and here's why I say that makes sense. I started with a negative in front, right? The rumor's not going to spread at a negative rate. People are not unhearing the rumor as you go. More people are hearing it every day, so I need a positive rate, right? Oh, this is getting fun. Okay. So it's going to be positive 300, 1 plus 2 to the 4 minus t, -2. And then I've got this 2, 4 minus t. I'm not even going to take this any further because it asked me how fast is it spreading after 4 days, right? So I'm going to go ahead and put in a 4 in here. I'm going to find the derivative at 4. I wasn't doing product rule on this one. I didn't have to because 300 was a constant, right? I wish I could take out that whole part where I think we should just. All right, so this is 2 to the 0. Anything to the 0 power is 1. So this whole thing here is going to become 2. Y'all agree with that? Because this is 1 plus 2 to the 0. So that's 1 plus 1, which is 2. This is just going to become 1 because it's 2 to the 0. So I'm going to have 300 times 2 to the -2 times 1 times the natural log of 2. This is going to be 300 over 4 times log 2, and I need to get an approximation on my calculator with this. I got 51.98. So I'm going to say about 52. Students per day. This one was tough, but it was fun. I like a challenge. No, you don't have too much. Let me just go into your homework. I kind of flubbed up giving you that. We shouldn't have even done that. I like logarithmic differentiation most of the time. Let's do. and it's an L. All right, these, I want you to do either, you can do logarithmic differentiation or normal, whichever you prefer. Then some multiple choice ones. One more, that's normal. Okay, and then your multiple choice. 65 through, no, this is an 8. Those are multiple choice. There's 4 more multiple choice on the next